In the next two slides, we'll talk about the concept of orthogonal complement. If a vector z is orthogonal to any vector or every vector of a subspace W in Rn, then z is orthogonal to W. Z is not orthogonal to one vector. Z is orthogonal to the whole subspace of W. Let's see an example here. We have a vector z along a line L. Z belongs to the space of L. We have W, which is this space over here. Z is perpendicular to any vectors on this space. The set of vectors, the set of all vectors Z that is orthogonal to W is called the orthogonal complements of W, or simply W perpendicular or W perp. So what is the notation that we will use? L, the line in this example, is equals to W perp, means it belongs to the perpendicular subspace of W. Corollary, L perpendicular is equals to W. We also note that W perp is a subspace of Rn if W is a subspace of Rn. Now we go to the next slide. We will now use our understanding of the word orthogonal complement in the matrix A, using it in the example of null space and row space. Specifically, if we have a matrix A that is dimension m by n, let us try a 3 by 2 matrix first. 1, 1, 2, 2, 3, 3 as a simple example. So the A matrix has dependent rows, and we have x and y. So this is Ax, the typical equations we know. The row space are these rows, any linear combinations of these rows. What about the null space? Remember that the null space is whatever the solution Ax is equals to 0 on the right hand side. So it means that the rows of A multiplied by this vector xy will give 0. This is exactly what the null space is. It is the set of solutions that will make Ax equals to 0. So it means that actually the null space is the orthogonal complement to the row space of A. The details is in this paragraph. Pictorially, it looks like this. If we see this as the row space of a m by n matrix A, and this is the row space, its row space A perp, the perpendicular space to the row space A, is the null space of A. And if you perform a transformation, so here we perform a transformation, and now we draw the column space of A, his perpendicular space is the null space of A transpose. Why is this so? Use the same example now. We perform a a transpose. We get 1, 1, 2, 2, 3, 3. And now the x vector, if this is A transpose, the x vector, now let's call this x1, x2, and x3. Now this belongs to R3. the row space of A transpose is R3. The rows of the A transpose multiplied by the X vector that gives you the null solution is perpendicular to the row space. Thank you.